Hello, and welcome to Algebra, Unit 3, Concept 2, Lesson 7. This is your last lesson. So, today our objective is scholars will factor special cases of polynomials. So we're going to look at special cases. Think back to when you did that patterns document last week. So, let's start here. Seth and Bailey are given the polynomial 8x squared plus 48x plus 72 to factor. We could see Seth's work here and Bailey's work here. First question is, are both expressions equivalent to the given polynomial? Well, how can we check that? That's easy enough. We can just multiply them out. So let's try multiplying them out. So here for Seth, I get 8x squared plus 24x plus 24x plus 72. Okay, well that one's equivalent because 24 and 24 will give us 48. And then for Bailey, we get, let's see, 8x squared plus 24x plus 24x plus 72. So yes, they are both equivalent. So the next question is, how can the product of different pairs of expressions be equivalent? I want you to think about that for a minute. How can the product of different pairs of expressions be equivalent? Is there something that could be factored out of each of them that would make it so that they were the expressions were actually the same? Think about that as we go through. So, what are the special cases? Again, we're thinking back to when we did the patterns document. We talked about them. So they are perfect square trinomials. You guys saw this. When you have a plus b squared, it multiplies to a squared plus 2ab plus b squared. So that's a perfect square trinomial. We're squaring a binomial to get our trinomial. And then you have the difference of two squares. Again, this is a plus b times a minus b, and it always gives us a squared minus b squared. Again, we looked at these on the patterns document that you guys did last week. So we're going to use that now. So Sasha has a tech store and needs cylindrical containers to package her voice-activated speakers. A packaging company makes two different cylindrical containers. Both are 3 inches high. Given the volume, determine the radius of each cylinder. How much greater is the radius of one container than the other? Okay, so the first thing we need to remember is, what is the formula for the volume of a cylinder? In case you remember, it's volume of a cylinder equals pi times the radius squared times the height. In this case, we know that they are 5 inches high. So let's start with the whatever here. Well, I look at this and I look at my formula pi r squared times h. I can see that with a height of 3, and then I know pi is pi, right? So all that's left in my formula is r squared. That means x squared must be r squared. Therefore, the radius is x. So for this one, the radius is x. The other one looks a little bit more difficult. So I know I can take out the 3 and the pi. The pi is already out, so I need to factor out the 3. So in this case, the volume equals pi times 3, the height. And then I'm left with x squared plus 10x plus 25. So we can factor this using the other methods that we've learned. Remember, I'm doing this because our h is 3, and pi, of course, is pi. Same thing over here, pi and h. Okay, so I need to find my radius. So I know that x squared plus 10x plus 25 must be my radius squared. And I'm trying to find my radius. So my radius squared is x squared plus 10x plus 25. I can tell looking at this, I see that this is a perfect square, x squared. I see that 25 is a perfect square, it's 5 squared. And when I look at 10x, I can see that that is 2 times x times 5. So in that case, I know that r squared equals x plus 5 squared, which means r equals x plus 5. So the question, how much greater is the radius of one than the other? Well, if the radius of the first one was x and the radius of this one is x plus 5, then this one has a greater radius by 5 inches. Not too hard. We just had to use our formulas. So let's try this one. And this time I want you to pause after I go through this. What is the radius of a cylinder that has a height of 3 inches and a volume of pi times 27x squared plus 18x plus 3 inches cubed? Pause this for a minute and see if you can find the answer. Hopefully you paused it if you didn't do it now. Okay, so again, if the volume equals pi times 27x squared plus 18x plus 3, we can factor out the 3. So I get volume equals 3 times pi times 9x squared plus 6x plus 1. And that is a perfect square trinomial. So the radius equals 9x squared plus, the radius squared, or x squared, plus 6x plus 1. Again, I'm looking and I see 9x squared is a perfect square. 1 is a perfect square. And 6x is the square root of each times 2. So that means that the radius is 3x plus 1, because this is 3x plus 1 squared. Okay? So that is the radius of that one. So let's look at factoring each of these expressions. Remember, we're looking for things to be the difference of two squares or a perfect square trinomial. In this case, this is a difference of two squares. I have x squared, which is a perfect square, minus 64. So this is x plus 8 times x minus 8. That's all I need to do. Let's look at this next one. 9x squared is a perfect square. 100 is a perfect square. 9x squared, the square root is 3x. And then, so we have 3x plus 10 and 3x minus 10. Nice and easy. All you're doing when you have the difference of two perfect squares is just separating them out. One more. This time, make sure we factor out the greatest common factor first. So in this case, my greatest common factor is 4x. So if I factor out the 4x, I'm left with x squared plus 6x plus 9. Well, I can tell looking at this that this is a perfect square trinomial. X squared is obviously a perfect square. 9 is a perfect square. So 9's perfect square is 3. 3x times 2 is 6x. So this is a perfect square trinomial. So my answer is 4x times x plus 3 squared. Now let's look at this final one. What can I factor out of 50x squared minus 32y squared? Well, I can factor out of 2. So I have 2 times 25x squared minus 16y squared. Again, now I am looking at the difference. Not what I meant to do. The difference of two squares. I've got 25x squared, which is a perfect square. I have 16y squared, which is a perfect square, and I am taking the difference of them. So, this is 2 times 5x minus 4y times 5x plus 4y. You just have to look for the patterns. Okay, go ahead and do your classwork, and I will see you in class.